Jai Hind to all. This is Akanksha Shukla from IT department, and today I am going to discuss one of the problem, and that is the statement name is problem solving examples, and the topic is related to subject AI, artificial intelligence. So today I will discuss basic problems just like water jug problem, cannibal and machinery problems, missionaries problem, and some more problems with the examples, so that how to solve the problem in AI can be very much clear to all. So the first problem is water jug problem. As the water jug problem states that there are two jugs given, one is 4-gallon jug and one is 3-gallon jug. A pump which has unlimited water can be used to fill that particular jug, and the ground on which the water may be poured, these are the things which is given in the problem. Okay, and neither the conditions, or we can say the constraint for water jug problem is that neither jug has any measuring markings on it. So the problem is that now how can you get exactly 2 gallons of water in the 4-gallon jug? So this is totally the problem which states that what is the water jug problem. So it is clear that given things are two jugs, one is 4-gallon and one is 3-gallon. A pump is also given and the ground on which you can pour the water. Now the limitation or condition is that neither jug has any measuring markings on it. So how can you get exactly 2 gallons of water in the 4-gallon jug? Here you can see that there are two jugs given, one is 4-gallon and one is 3-gallon, and the pump is also given from which you have to calculate the exactly 2 gallon of water in this particular jug. Okay, without any, this jug is, you can easily see that there are no measuring markings on these two jugs. So how can we solve this problem? So we solve this problem further, but let's suppose what are the state representation for this problem. So we will represent a state of the problem as a tuple just like x and y, where x represents the amount of water in the 4-gallon jug and the y represents the amount of water in the 3-gallon jug. So what are the initial states for this given problem? As if you have studied the problem formulation in AI, then each and everyone knows about the problem formulation for a given particular problem. So the problem formulation states that what are the initial states, what are the goal states, what are the constraints for that particular problem. So as per consideration, what are the initial state for this water jug problem? That initially we have 0, 0 states. Okay, means the x and y, the amount of water in the 4-gallon jug and the amount of water in the 3-gallon jug is 0. Means we have taken the 4-gallon and 3-gallon jug as a empty in the initial state. Okay, and what is the goal state? That we have to consider 2 gallon of water in this 4-gallon of jug, and y should be remain same, simple or whatever you want. Okay, main condition is that you have to put exactly 2 gallon of water in the 4-gallon of jug. This is the goal state in this particular problem. Okay, so move on to the production rules for this particular problem. Now we can see that initially we have x comma y, and if x is less than 4, then the production rule will state that 4 comma y. Now the second production rule states that if y is less than 3, then the production rule means if y is less than 3 tends to means x comma 3, means y is having 3 gallon of water in it. Now if x is greater than 0, then what? We are going to subtract that particular water from that particular gallon of jug, means from 4 gallon of jug we are going to subtract x minus d, and if y is greater than 0, then same we are having the same condition for 3 gallon of jug. If x is greater than 0, second condition can be stated that 0 comma y, and if y is greater than 0, then next statement is that x comma 0. If x plus y both is greater than or equal to 0 and y is greater than 0, then what production rule will state that 4 comma y minus 4 minus x. Okay, and similarly, if the value of x is greater than 0, then x minus 3 minus y comma 3 will state as a production rule for this particular problem. Next one is if x plus y is less than equal to 4 and y is greater than 0, then what production rule tends to become? It becomes x plus y comma 0. If x plus y less than equal to 3 and x is greater than 0, then the production rule tends to 0 comma x plus y. Next one is 0 comma 2, and 0 comma 2 means it can also tends to 2 comma 0. Okay, so these are the some production rule for that particular water jug problem. Basically, the problem is that we are having two jugs, both are empty, and we have to pour the exactly 2 gallon of water in this particular 4 gallon of jug. So the solution can be in one of the representation that suppose we had pour all the water in 4 gallon jug. Okay, now what we do, this 4 gallon jug is full now. Now we pour 3 gallon of water into this. So in this only 1 gallon of water remains, and this is full with 3 gallon of water. Now what we did? In this particular problem, what we want to achieve, that we have to achieve exactly 2 gallon of water in this particular jug. Okay, so what we do, we can pour this 1 gallon of water into the ground. Okay, we can pour 1 gallon of water into the ground. Okay, now this 4 gallon water tends to empty. What we do, we pour this particular 3 gallon of water into this. Okay, and after that what we do, we pour 1 gallon of water from this to this, from 3 gallon to 4 gallon of water. After that, when we pour this particular of water into this 4 gallon of jug, then that particular jug will have exactly 3 gallon of water. Okay, now when we pour this 3 gallon of water into the ground, then again the problem remains same, that we are having again the both the jugs empty. Okay, so what we do, we fill just like following these production rule. What we are doing, we are first of all what we are doing, we are filling 4 gallon of jug with fully, we are going to fill 4 gallon of jug. After that what we are doing, we are pouring 3 gallon of water. We can simply say that we are going to fill this 3 gallon of water, 3 gallon of jug. So simply what is the condition, that x comma 3. Now what we are doing, we are having two conditions. You also can pour the water from 4 gallon of jug, and you also can pour the water from 3 gallon of jug. Whatever the water both the jugs are having, you can have two conditions. You can pour all the water from 4 gallon jug also, or you can pour all the water from 3 gallon also. Okay, so next condition is if x is greater than 0. So currently in this particular jug we are having the value 1 gallon of jug. So we pour all the water from this. Okay, now what this production rule is saying, that if x plus y is greater than or equal to 4 and y is greater than 0, means if both the jugs are having the value greater than or equal to 4, okay, and y is greater than 0, means this is having 3 gallon and this is having 1 gallon. So if we are adding both the jugs, the quantity of water of both the jugs, then we are having the value greater than or equal to 4, and also y is greater than 0. So what we are doing here, we are doing y minus 4 minus x. Okay, so sorry, we are doing this 4 means in this particular 3 gallon of jug we are performing y minus 4 minus x. So currently y is value 3, 4 minus 1. So 3 minus 4 minus 1, 3 means we are going to, in one condition we are going to empty this one. So from, if you are following this production rule, then it will give the result at 4 in this particular gallon, 4. This is completely full and this particular jug is having value 0. Similarly, if you are going to follow the second one, then we are having x minus 3 minus y comma 3. Okay, so x value is, if x plus y is greater than or equal to 3, so what is the value of x? In x we are having 1, 3 minus 3, 1 minus 0 comma 3 means in this 1 and in the next one we are having 3 gallon of water. So 1 comma 3. Now x plus y comma 0. If x plus y is less than or equal to 4 and y is greater than 0, then production rule will state that x plus y comma 0. And if x plus y is less than or equal to 3 and x is greater than 0, then 0 comma x plus y means both the conditions. You can apply the conditions in 4 gallon jug also, in 3 gallon jug also. Okay. And in last, what we achieve? We achieve the goal state, that is 2 comma 0 means in 4 gallon jug we are having exactly the 2 gallon of water. Okay. So simply what we are going to achieve, that at initial level both the jugs are empty and finally we are going to achieve the exactly 2 gallon of water into 4 gallon of jug. Okay. So if you are having, we are having some conditions just like 1 comma 3, just like 4 comma 0. Okay. So by applying all these production rules, we can easily achieve to our goal state, that is 2 comma 0, which I have shown here only. Okay. Now this is the search tree of water jug problem, that initially we are having both the jugs empty. Second states, in second state we can have 4 comma 0 means we had filled the 4 gallon of jug fully, and in this what we do, we pour exactly 3 gallon of, we fill the 3 gallon of jug exactly and empty the 4 gallon of jug. Now these are the some results from these states. We can perform these some states and we can also perform these some states. These are the some search strategies we are going to perform for obtaining the result or for obtaining the goal state, that is 2 comma 0. Okay. So these are, simply we can say that this is the search tree which indicates that what are the some states from initial state to goal state, what are the some intermediary steps or states which a particular water jug problem can have. Okay. So simply this is the representation of that only. Now next problem which I am going to discuss is 8 queen problem. Okay. This simply we can say that n queen problem. We can say that n queen problem. Okay. This n can have any value. Generally this n have 4 comma 8 comma 16. Okay. Means this n can be varied. Okay. So here I am going to discuss only 8 queen problem. So the problem is placing the 8 queens on a chessboard so that none of them can attack each other. Okay. So what is the problem statement? Then we have to place 8 queens on a chessboard so that not a single queen can attack anyone. Okay. So the formulation 1 is that a state is an arrangement of a 0 to 8 queens on the board and operators add a queen to any sequence. The formulation is, in this particular problem, the formulation is not a systematic way to find a solution. It takes a long time to get the solution because some constraints or limitations here also applies. Okay. The limitations or constraints which n queen problem have, that no queen can be placed in the same row, no queen can be placed in the same column, and no queen can be placed in the adjacent columns. So these are the constraints which are going to be applied in that particular n queen problem. By applying that constraints or limitations only, we are going to find the solution, that how the 8 queens can be placed in a chessboard so that none of them can attack each other. Okay. Now formulation 1 is given and formulation 2 I had already told that not in the same row, not in the same column. So the formulation 3 is that a state is an arrangement of 8 queens in each column. Operators moved on attack queen to another square in the same column. Keep on shuffling the queen until the goal is reached, which I had told, okay, that none of the queens can be placed in the same column, not in the same row. So we have to perform shuffling, okay, until the goal state is reached, that no queens can be placed in the same row, same column, not on adjacent column. Okay, so this formulation is more systematic, hence it is called as iterative formulation, that we are going to perform the shuffling until and unless the goal state is achieved. So this is the 8 queen problem 1 solution, because it is a iterative formulation, or we can have the solution by performing the iterations multiple times. So here I am not going to perform all that iterations, okay, because it takes a time. So directly I am going to show you the solution, that how 8 queens can be placed on the chessboard without attacking each other. So you can see here single row in the single queen in the single column. So sorry, row. Here also, here and so on. Okay. No two queens are placed in the same row. Now check the column also. No two queens are on the same columns. Okay. And in the adjacent also, no two queens are placed in the adjacent rows also. So this is the proper 8 queen. This is the proper solution for a 8 queen problem. We can see here that no two queens are placed on same row, same column and on the adjacent. So that it means that no two queens can attack on each other. Now what is the 8 puzzle problem? So here in the 8 puzzle problem, we can see that we are having 3 cross 3 board, okay, and this is the start state and this is the goal state. Okay, so in 8 puzzle problem, what we have to do, we are giving a initial state or a start state. Okay, now we have to reach the goal state by performing some actions. Okay, these actions can be the movement of moving up, down, left and right. Okay, so 8 puzzle problem. In the 8 puzzle problems, what are the problem formulation for that particular problem? First one is, what are the state spaces for that particular problem? What are the location of each of the 8 tiles? And in the blank tile, what is the start state? What are the starting configurations you are going to perform? What are the operators? So I had told that 4 operators are going to be performed in 8 puzzle problem. That 4 operators are right, left, up and down. So you can, the tiles can be moved up, down, left or right to achieve the goal state. And the goal, it is one of the goal configuration. Okay, so simply these are the problem formulations which are going to be used while we are going to solve the problem. Now this is the 8 puzzle tree. Just like in this 8 puzzle tree, we are having, this is a initial state. Now from that particular initial state, we are going to perform, here we are performing which operation? We are going to perform, suppose I am standing here. So this side we are going to perform right operation and this side I am going to perform left operation. Okay, and top and bottom is up and down operation. Okay, so this is the right operation and here this is the down operator, and here also we can, this is the blank space, sorry. So this is the left operation. Okay, and here what we are going to perform, that 4 is placed here. So this is also the right operation, and in this 6 is moving up. So this is the up operation, and here 8 is moving this side. So it is the left operation. Okay, so by performing all the operators, just like up and down, means we are going to move the tiles from their position to left, right, up and down, and now we are going to achieve the goal state. Just like in this particular problem, we are having this start state this, and we have to achieve this state, that 1, 2, 3, 4, 5, 6, 7, 8. So what we do? We perform operation. We can perform first operation, that is moving 6 towards the right. In the second operation, move 7 to up, okay, and in third operation, move 1 to upward, okay. Now move 7 to this side and then 1 to upper side, then finally 1 can come here, okay. So by performing multiple times of these iterations, okay, we have to perform multiple iterations, then only we are going to achieve that particular goal state from the initial state. So what we have to do, simply you have to perform the multiple times, you have to perform the operations multiple times, means we are going to have multiple iterations to achieve the goal state. So simple, you have to perform the iterations, and you have to keep in your mind the thing that you can have a goal state with minimum number of iterations. So you have to identify the places, identify the tiles, that by moving which tile we can have the goal state in minimum number of iterations. So this thing you have to keep in your mind while solving these puzzle problems. Now the next problem is missionaries and cannibals, which it is a very interesting problem. That in this particular problem we are having a statement, we are having a problem statement given, that is 3 missionaries and 3 cannibals are initially given, and they are finding themselves on a side of a river. They agreed to get on the other side of a river. Both are agreed to go on the other side of a river, but missionaries are afraid of being eaten by cannibals. So the missionaries want to manage the trip in such a way that number of missionaries on either side of the river is never less than the number of cannibals on the same side. This is clear that missionaries are afraid of being eaten by cannibals, so they want to manage the trip in such a way that number of missionaries on either side of a river is never less than the number of cannibals on the same side. So number of missionaries means always greater than number of cannibals on the side of the river. The boat capacity is able to hold only 2 people at a time. So this is the solution for that particular problem, that at initial step we are having 3 missionaries, 3 cannibals, okay. This is a boat, okay, and now from first step 2 cannibals cross over, okay. So 2 cannibals cross over by the boat, okay. In the next condition, 1 cannibal comes back, okay, and then 2 cannibals go over again. So here we can have 3 missionaries on one side and 3 cannibals on one side. Then again 1 come back, 1 cannibal come back, because always the number of missionaries will be greater than number of cannibals. Then what happened? The 2 missionaries also cross over the other side of a river, okay. Then a missionary and cannibal can return. So from that side 1 missionary and 1 cannibal return back. So both the side we can have that number of missionaries greater than cannibal. Then 2 missionaries cross over again. So 2 missionaries cross over again, and then a cannibal return back. Then 2 cannibals cross over the other side, okay, and then 1 return, and then 1 brings over the third. So you can have the solution that all the missionaries and all the cannibals from one side of the river can reach or can move on over the other side of the river. So the initial state is that all the missionaries and cannibals are one side of the river, and in the goal state we are having the all missionaries and cannibals on the other side of a river. So this is the particular solution for that particular problem, that is missionary and cannibal problem, and that's all for today's lecture. Thank you.